of India. Yes, the introduction part, we can see the formation of Earth. The formation of the Earth, the Earth crust, it is mainly it was formed by the three types of rocks. We know that one it is igneous, second one it is metamorphic formations, and third one it is a sedimentary formation. The surface of the Earth, it has gone different process, and the processes are happening continuously, and it's need by the geological changes. The more than approximately some more than three-fourths of the Earth's surface, we have different formations. Yeah, some of the sedimentary rocks which are characterized by the presence of a bedding. That means these beddings or beds are formed by the one layer by the another layer. So we see these layers like a small leaf or a lamina type form will be there. That is known as a stratification. So these stratification results, uh, which leads to deposition of sediments horizontal layer. The igneous and the metamorphic rock formations, which are showing a different bedding. Then the stratified rocks are whatever layered formations we see, particularly in a sedimentary formation. Here, the sedimentary formation, sometimes what is particularly some of the gaps will be freed. The gaps will be formed by the are occupied by the volcanic activity. The volcanic formations will be seen along the layer. So especially the sequence which is happening in a particular the time. So it is related to the specific characteristics of a little. So that we will know that is not as a stratigraphy or historical geology. It is showing the history, of the geology. Is again our Indian subcontinent is broadly divided into the three regions. One it is a peninsular India. The second one is extra peninsular, and third one it is a Gangatic alluvial plain that is known as a Gangatic alluvial plains. So principles of stratigraphy. There are some principles we have. Whatever the earth formation or whatever we see, the layers means the earth formation which is formed by layer. The sequential arrangement will be there within a rock. So these layers, they will form according to their formation of the surface of the earth, which is having. Layer by layer, it is going to be formed according to that. These layers will be formed. The chronological sequence of a rock formations, which are established in terms of their relative age, and graphically it is represented into the vertical columns. So here the earlier whatever voltage or earlier formations they arranged in the vertical columns which are arranged in a bottom, and the rocks which are deposited later, so that the later means younger. The first one, whatever formed, we are calling those are known as the earlier formations. After the earlier formations, the another rocks will be forming a layer by layer. Those top rock, top areas, whatever we are having, those rocks are known as earlier formations or younger formations. So that the rocks, whatever younger we see, the younger formations which are preserved advanced forms of organism. study of these organisms, which are called fossils, the fossil helps the determination of the age to find out the particular age of the rocks, and which are having the fossilities of the rock formations. Based on that, we will have a chance to find out the age of a rock. There are various rock formations we see on the surface of the Earth, and those will be deposited more than almost 500 million years ago. Generally, it is a divide of any fossil record. Yes. For determining the relative of age between on the fossilities as well as unfossilities rock, uh, unfossilities of the rock. So that for that studies, we will have to follow some principles. These principles are known as the principles known as giving the information about the stratigraphy. So that we are calling these principles are known as the stratigraphy, principles of the stratigraphy. Yeah, one more, next one, it is the order of the superposition. Here, the order of the superposition, we know that there are various geological formations which rest on another side which is superimposed by the other. Yeah, the formations are a bottom which are naturally older. That means wherever you can see the lithological formations, the bottom areas, the bottom formations are having the older age or older formations. Then when we compare with the top formations you can see the top formations are having the younger formations. So that here each overlying the bed is younger than the underlying bed in the normal conditions of the stratification. So this principal order is known as a law of the superposition. Law of a superposition. The law of the superposition means here the older rocks will be formed. I mean the older rocks will form in the bottom area, and layer by layer above the area or above the layer of this older one, the younger the youngest will be formed. So that the youngest will be forming. Otherwise, they are going to be formed. The first phase is occupied by the older one, and the second phase are up to while we are coming to the towards the top side. These are occupying or formed by the younger ones. So this position it is known as the order of a superposition or a law of superposition also we call. Yeah, based on this principle, we can determine. Based on this principle, we can determine the relative ages of sedimentary and volcanic rocks, which are having the simple structures. Yeah, in this case, the distribution of the rocks, the top and bottom of beds at the time of their deposition are determined with the help of the sedimentary structures like current bedding, graded bedding, or ripple marks. These are all we can able to see on a surface. Yes, you can see here figure 1.1 is showing as a geological cross section of a horizontal bedded formation. Here, just you can see here it is a horizontal arrangement of a section, and whereas it's a cross section of a geological cross section of a distributed formation. There are different types of formations there, and it is showing as A, B, C. A, the C, A, it is showing the lower beds, and B, it is showing here somewhere, and C, D, and E, and F. So the A, it is a older ones, and whereas the F, it is a younger ones. Now, what is the lithological character? The lithological character it is a useful for to study of and dividing the rock formations in a particular sequence into the formation. Each lithological unit may consist a number of individual beds having more or less the same characters, where it is called the formation of a different age or belonging to one to another age. So based on this, what we can understand? Here the lithological character, it is giving the information, the formation of rocks and which are having the characteristics. Like example, just if you can see the Barakar sandstones or a Kamti sandstone or a Kumbam slate or a Vempali limestone, etc. and etc. There is it is a very creating the correlation between the one rock formation to the another rock formation. The correlation of the rocks for two areas often we carried out by comparing the lithological characteristics of their own formations, how these formations, how they are formed, and what type of characteristics are having. It is taking the correlation. The correlation studies it's done by tracking the various characteristics of a bed formation. Such beds are known as a marker beds. Those beds are known as a marker beds. The rock formations, which occur between the two marker beds in a neighboring areas are considered to be of the same age. Just example, if you see the Barakar sandstone of a lower Gondwana, it is mainly exposed in Jharia coal belt or a Jharia coal field and consisting of bedded feldspar bearing sandstone. Or sometimes we say the grids, and again occasionally it is an association of a conglomerated shales also. So that here the Barakar sandstone, which is belongs to the lower Gondwana formations, I mean it belongs to the lower Gondwanas, and it is exposed, particularly it is exposed under Jharia coal deposits or a Jharia coal field, and consisting of bare feldspars bearing of a sandstone, or sometimes we see the association of grits and conglomerates and shales also. So that you can observe here the lower Gondwana fields. The lower Gondwana, it is exposed on Jharia coal. The Jharia coal is association with conglomerate beds and shales also. So the formations are different, and again, the basic thing it is the basement. I mean, the basic thing it is consisting of or associating with a feldspathic sandstone. Feldspathic sandstone. Again, the same type of the rock formations we see in a Raniganj, whereas in Darjeeling conglomerates, Darjeeling, Assam and Sikkim areas, the same areas also are having the which are called as Barakan and sandstone formation. These rock formations, which are belong to the same age, but deposited in different sedimentary basins, so that we can say the lithological characters may be different. For example, if you see the Permian rock formations of the salt range, product limestone, it is lithologically different from that area of Spiti and others. What about the structure and tectonics? The sediment deposits are sedimented deposits in various sediment formations or the sediment basins which are uplifted above the tectonic movements. The sedimented deposits in various sedimentary basins sometimes maybe which are uplifted. Yeah, the movements are known as a tectonic movements here, which deform resulting in various structures in different rock formations. So that the gap will be forming. The gap will be forming means the gap which is going to be deposited or it is depositing by the another material. The gap it is fulfilled by the some of the deposition. The gap it is known as a non-deposition period. Yeah, this is important to see here. Whatever tectonic movements occur is a deforming result in various structures in the rocks. Then there will be a gap in the deposition. So the deposition it has a gap. The deposition it has a gap. The gap it is known. The gap it is known of the period. It is known as a non-deposition formation. Non-deposition. The later deposited sediments in the basin are not comfortable, or maybe it is not conformable with earlier developed sediments, so that the surface separating separating the two successions. Yeah, just you can see here the picture. It is indicating by the numbers 1. Here you see here it is a 1. Then next one it is a 2. And third one it is a 3. Yes. In a surface of unconformity, it is showing as a post granite A and B. You see here, post granite and B is showing as a post dolerite formation. Post granite means after the formation of the granite, and it is indicating as a post dolerite. This is a dolerite, it is a younger rock. So that the first one it belongs to the lower group. It belongs to the lower group, and second one it is a middle group. This one it is indicating as a middle group, and third one it is the upper side, the upper group. Yeah, yes. The first one it was formed. Here you see it was formed. Yeah, this one it was formed in a bottom space, in a lower area, and it was formed first time. So that's the reason it is occupied the first position. The second one, the first one is covered by the second. The first one it is covered by the second. It is approximately it is a middle group or a middle formation. It is having the middle characteristics, and it's showing the middle formation. Then the third one it is upper group formation. It was formed later onwards, maybe after the dike formation. Because of the dikes are the younger intrusions. These dikes are the younger, so these yangers will form later stage. So that the first basement it is occupied by the granite or whatever it is that the basement of granite, and always the basement granite is the youngest. Sorry, boulders. Later, the dolerites or whatever other formations will form along the intrusions. Afterwards, formation of these granite, those rocks are known as younger granite. For that example, that is known as a dolerite. Okay, now what is unconfirmed? Unconfirmed. So here, the non-deposition part or the non-deposition area, whatever it was found there, whatever it was found there, it is separating the areas. It is separating the areas, and it is dividing into the two areas, and but we didn't get any formation, or we didn't get any mineral deposition there. It is look like as a gap that is known as a non-deposition area, and as well as it is divided into the two parts as a two successions, as a two succession of the rock formations. It is known as a surface of unconformity. It is known as a surface of unconformity. Then it is either a surface where it is the erosion or a non-deposition. The sequence or a rock sequence or rock formation sequence of an area can be divided into the major rock groups so that it will be separated from one another by a surface of unconformity. In the period of an unconformity, it is commonly evidenced by the presence of a conglomerate by the presence of a conglomerate. If there is no visible break and the formation show complete parallelism in spite of a gap in sedimentation is called disconformity. The first one, it is an unconformity. The unconformity, the gap was formed here and it is separating the two rocks. And it is separating the two rocks. Separating the two rocks, sorry. Yeah, it is separating the two rocks. So there is no deposition along that gap. It is a non-deposition. So that it is known as unconformity formation. But here it is something is a different. I mean, it's different from the unconformity. Yeah, it is actually it belongs to the unconformity. But the unconformity sometimes maybe we see in the unconformity the conglomerate presence of a conglomeration. Sometimes maybe what is happening, there is no visible break or formation. Completely it is a parallel in spite of a gap of sedimentation, in spite of a gap in the sedimentation. It is known as a disconformity. It is known as a disconformity. Formations lying between the two successive surfaces, surfaces of unconformity is near areas or neighboring areas, which is considered to be same age. So that these tectonic movements are also recorded within a single group of rock succession in the form of a rhythmicity of the different lithological types. The basin of a deposition may undergo successive phase of deepening or shallowing which are reflected from a deposition of sediments. Then we see the alternative in the basin also. So that the presence of a sandstone is indicating the way the shallow water deposition are having, or the shades of a deposition we see in the deep water deposition. Next one, it is fossil records. The organic remains which are preserved in a rock mostly widely used for determining the relative of a age of a rock formations and deposited during the last 570 million years. The type of organic remain preserved in a rock, which is indicate the kinds of life which existed on the earth at the time of the formation of these rocks. Such fossil records are more reliable for determining the relative age of rock formations and their correlation over large areas. This method is based on that the given faunal or floral assemblages is never repeated again in the geological time, and the organism continuously undergo changes in the morphology. The biological evolution that reveals that the organisms cannot be evolved, and it is a proceeding from even if they find themselves in exactly similar conditions in which the processes are lived. Yeah, there is each assemblage of past life preserved in a rock reflects It is indicating at a specific stage, and it is showing the specific evolution of that area. Generally, the index fossil assemblage and the microorganisms which are used for a mainly this tool determines the relative age of different beds in the rock succession. The next one is index fossils. Yeah, some of the extinct organisms also be found, and they widespread on a geographical areas. Depending on the geographical conditions, they may distribute throughout the area, or sometimes maybe depend on the conditions and restricted in particular area. So such extinct organisms are known as index fossils. That means here, whatever organisms which are in the extinct stage, and these will be limited or occupied or lived in a particular age. Example for if you see the dinosaurs you can see the Jurassic age, almost Jurassic age particularly seen. But after that, sometimes they have been used, but later they diminished that area and completely the dinosaurs extinct. So we can say yes, these dinosaurs are belong to the so particular age of geological times. So that these these are known as index of the fossils or index fossils. Yeah, one more thing it is, for example, for this one, the grapholites. The grapholites, mainly we have seen the different rock formations. They were distributed in particularly the age, that is Ordovician period, but completely they were extinct of the same rocks of Silurian period. Silurian period. These were occupied or they were lived from Ordovician period to up to the Silurian period. So these grapholites were restricted to that area of age only. Second one, it is trilobites. The trilobites are mainly dominant during the Cambrian period, in a particularly Ornelas, which was lived in the lower Cambrian, and Paradoxites lived in the middle Cambrian, and Bornis, which is lived in the upper Cambrian. So each one it is having the specific age, and they will have lived in a specific rock area and specific area of a globe. Now, what is the use of fossils in the index fossils? The index fossils, which are useful for stratigraphical classification and also which is useful for correlation studies, and it's considered as one of the quickest methods. It's a very easy method and the quickest method to find out the age of a fossil. The index fossils have a wide geographic distribution within the short interval of geological time. Ignoring the limitation of the conditions of a habitat in the view of a limitation of fossils, the local fossil assemblages of the beds are examined and compared with those other rocks. Just 1 minute. Yeah. Yeah, generally these index fossils, what is the main use for this? This method which is used for to find out the particular age, the particular age, or sometimes maybe we see the geographical conditions, geographical distribution of different fossils. Yeah, fossil assemblages. The fossil assemblage, the total number of fossils which are preserved in the rocks will be taken into the account regarding the relative of ages of different rock formations. One group of fossils can be cross-checked with the other group of fossils preserved in the same strata. The presence of a same species of fossil assemblage in the rock formations, which indicate the ecological conditions at the time of a deposition. Definitely, at the time of a deposition, it is useful. Yeah, such species which inhabited on the surface of the earth during the time of a deposition of a particular stratigraphic unit and which are preserved as fossils in such unit area, which is useful for stratigraphic classification and the correlation. Yeah, there are some microorganisms also there, those like the microorganisms like the foraminifera, radiolaria, arthropods, diatoms, pollens, spores, which are extensively used for determining the relative of the age of a particular rock formation and their correlation. The microfossils, because of their small in sizes, can be collected even from the cores of the bore samples. Yeah, from the bore samples also will collect these the samples, and from these bore and the core samples, we see these are all in very small sizes. The collection of microfossils which are identified in the laboratory and which are useful for to help the stereo microscope and spectro microscope and electron microscope. Yeah, nowadays the foraminifera of the very foramins are playing a very important role for the classification studies. Yeah, yeah, there are some methods are there to find out the relative of ages. So first we see the geophysical methods. The geophysical methods are the geophysical instruments which are help in the measurement of a certain physical properties of a subsurface of a rock earth formations, which involve the field measurement of certain properties like gravity, magnetism, seismicity, and electrical resistivity of different rocks with sensitive instruments. The geophysical data can reflect the lithological characters of the rock formations, and it can be used stratigraphic classification and correlation. So that the electrical and gamma rays also, we have an electrical and gamma ray logging or a gamma logging methods. These are also useful mainly to classify, mainly the stratigraphic investigation, and which is useful for to find out the correlation studies to one rock to the another rock. Yeah, one more thing, it is electrical and gamma logging methods. These electrical gamma logging methods are mainly it is used to in stratigraphic classification only. Then electrical logging, it is a function. It's a function on the electrical resistivity of groups. Yeah, the electrical logging is a function, the electrical resistivity, it will be depend on the electrical resistivity of a rocks and gamma ray or gamma logging and the content of the radioactivity of a rock. What is the purpose? For the purpose of a stratigraphical or stratigraphic investigation, the special instruments are lowered in the boreholes, which record the which record the changes to physical properties of a rock using the recorded data logging diagrams are prepared showing the sequential change of a physical properties which are observed along the depth of the rock formation. Therefore, these logging diagrams can be used for correlation of a neighboring areas. Seismic geophysical methods known as seismic stratigraphy. Yes, it is known as a seismic stratigraphy. It is useful for to study of a stratigraphy and exploration of a hidden mineral deposits, whatever having. As the seismic waves while traveling through the subsurface of a rocks and reflecting the uh, rays and the refraction from the different interfaces of the formations, rock formations, and so giving the information, the changes, how the changes occurred in a rock, and while it's producing the changes in the reflectivity, which observed in the seismic data. We can observe the seismic data. Does rock type change indicate the stratigraphic changes? The most commonly used in a data seismic method, we see that is on P waves. It's written on the P wave reflections. The paleomagnetism it is also playing a very important role. So that we will consider it is as an important tool for stratigraphic correlation of xenozoic rock formations. In a xenozoic rock formations, in the Geology rock formations, it is known as the position. It is known as the position of X magnetism, and it has been changing the its polarity over a period of a geological time. The magnetic metals or magnetic metals or minerals, whatever which are having are present in the core, is metamorphic. Yeah. So the paleomagnetism, it is a useful for to find out the X magnetism, how it has, and the magnetism, how it is going to put changes in the polarity over the period of a geological time. The magnetic minerals which are present in both in sedimentary and as well as in igneous rocks, which are heavily rocks retained recording the magnetic field at the time of a place of the formation. Such rock samples polarity is recorded in terms of a normal or reversal with respect to the present pole orientation of the Earth magnetism. For example, in a succession of Deccan volcanic rocks, the four successive magnetic normals and reversals have been recorded particularly. We can see in these normal reversals and the normal magnetic formations we see in a Deccan volcanic rocks. What about correlation? What about a correlation? The correlation is an important aspect in a stratigraphy, which aims at matching the rock formations of different areas deposited at the same stage of Earth as evolutionary history. Such two formations are deposited at the time of at the same time, which is referred or it is known as a homotaxia. If two formations are not formed in the same time, it is indicating not same, it is indicating as a synchronous in other region. A standard geographical or standard stratigraphic scale that is known as a geological time scale has been published or established for a correlation of a matrix in a rock sequence of different regions. Yeah, now we see the standard stratigraphic units. The Earth scientists, their opinion, the Earth was born before 4.6 billion years ago. Since then, experienced several geological events. These events are recorded in the rock formations as the pages of the Earth history. The rock sequence they can see which were deposited during the certain duration it's required for geological activity and which contain the characteristics of a deposits. Yeah, the sequence of which may deposited during the certain geological duration of a geological and which contain characteristic fossils and which constitute the chronostratigraphic or time graphic units. Thus, the chronostratigraphic units representing the certain course in Earth history, and for each chronostratigraphic unit, there is a corresponding geological time or units or a time unit will be there. The chronostratigraphic units again are divided into the almost 6 parts. One is the series, and second one is the stage. Third one is the zone. Fourth one is into the years, and sixth one is epochs. Fifth one is epochs, and sixth one is the age, and final one is the phases. The standard chronostratigraphic scale is not suitable for stratigraphic weekends or unpleasant strata. In the view of these limitations, a new scheme classified of the rocks succession, which is follows the basic principles of stratigraphic classification and correlation. In this classification group will be broad cross unit and the constant. Yeah, the constant. Yeah, the classification which follows basic principles of stratigraphic classification. It's related to the correlation. In the classification group, there are the broadest unit and the consists of a fixed succession of rock formation spread over the large area. A group which is divided into more than one formation. One formation into the member into the bed. That means here the formation into the member into the bed. An association of a mutually related group which is known as a supergroup. Just you can see here geological time units, the chronostratigraphic unit, and third one it is correlation of a lithostratigraphic units. In a geological time scale unit one, the unit is known as a era, whereas in chronostratigraphic units that we will see by units and lithostratigraphic unit it is known as a scale. Next one is the period. Yeah, the period is showing as a tertiary period. We in this area, in the chronostratigraphic area, it is called as a system. Yeah, it is a tertiary period, so that tertiary system, and It's also not. Oh, the interrelationship. Era it is divided into the period in the geological time units, and period it is divided into the epoch. Epoch it is divided into the age. Age is divided into phase. Example for this one: Cenozoic era, Tertiary period, and Miocene epoch, Pannonian age, and Global area, and Tumida. These are all the best examples for this geological time units. Okay, now we say in econographic stratigraphic units. Here again, it is equivalent to the era. It is known as eratum, and period it is equivalent to the system. Epoch it is equivalent to the series. Age it is equivalent to the stage. Phase it is equivalent to the zone. Again, there are some examples as given here. Period it is belongs to the tertiary system. Epoch it is divided as a series. It is known as a Miocene series. Age belongs to the Pannonian stage. You see here it is known as a stage. Stage it is equal to the age. And final when it is the phase it is equivalent to the stratigraphic age. It is known as a zone. The best example for this one, Tumida. Yeah, final when it is a lithostratigraphic unit. The lithostratigraphic unit again, the basic unit it is known as a group. Group it is going to be divided as a formation. In the further formation, it is divided into the member. Member it is divided into the bed. So you see here there are three units. We see era it is separate from these two. Whereas period it is equal to the systematic chronographic stratigraphic unit, and the system it is equal to the lithostratigraphic unit of a group. Epoch equal to the series equal to the formation in a lithostratigraphic unit. Age it is equal to the stage it is equal to the member of lithostratigraphic units. Whereas the phases again equivalent to the zones equivalent to the bed. So there are three types of units are there. One is the geological time unit, second one it is the chronostratigraphic units, and the third one it is a lithostratigraphic unit. And again, these groups and the formation of members and the beds also divided into some other parts based on the formation. Okay, later we will discuss tomorrow. Thank you.